Last meeting, I started with concrete, steel concrete composite columns. And I started with the encased composite column. Encased means we have steel column embedded in concrete. How can we figure out the compressive design strengths of this column? We have these steps, and we covered one example last meeting. Okay, what will happen if you have this column under tension? Let me explain something for you first. So guys, when you expect tension on a column, anybody can answer this question? When you can expect tension on a column, when the column will be under tension. Anybody has any idea? You are working on capstone project right now, and I think Burak and his group found there is a column under tension. So can you tell me when we can find a column under tension? Lateral forces. Anything else? Lateral forces are the only cause for tension. Okay. Your situation, Burak, is not recommended. Can you see? If we have continuous beam like this, we have beam supported by 3 columns. But for some reason, based on the layout of your column, I found we have one span very large, probably 30 feet, and one span of the continuous beam is 10 feet or 5 feet or whatever. For some reason also, due to the layout of the floor, this huge or this long span has a huge amount of dead load and the live load. However, the smallest span beside stairs or beside the sky opening or beside the elevator or something around this span cause very small value of live load. So based on the structure analysis, I believe the deformed shape of this beam looks like this. And if you calculate your reaction using RISA 2D or RISA floor, you will find this reaction will be vertical, this reaction will be vertical, this reaction will be down. That means this reaction will cause compression on the column, this reaction will cause compression on the column, this reaction will cause tension on the column. We don't like this scenario. We don't like this. That means your layout of columns is not efficient. That means you made one span very long and the other span very short. That means the layout of your columns should be adjusted to make sure all columns under compression. You know, guys, dead load and the live load can be called gravity loads, which means everything in the structure under the effect of downward force, which means any column in your structure should be under compression. If you found reaction cause tension on the column due to gravity loads, your statical system or something wrong in your system, layout of beams, layout of columns, layout of loading, something should be adjusted. That makes sense? As I told you, dead load and live load named gravity loads. Gravity means downward force. Everything is going down. So your column should be under the effect of compression loads. Does that make sense? Okay. Your issue, I think you made one span very long and one span short, or you made two columns are very close and the other two columns are very far away from each other. Does that make sense? Anyway, also sometimes here is the plan of your slab. Sometimes we have stairs. And you put column here and the column here and the column here and the column here. I think this is the case. Probably this column at the corner of opening, because this stair can be called opening, sky opening or something in the floor. So probably this column will be under tension due to gravity to load, dead load and live load, because you put another column very close to this column. We don't like this. You have to figure it out to solve this issue. Anyway, the second case, if you have high-rise building and at the same time we have vertical load, which is dead plus live, and we have lateral load. I know the dead load, I'm talking about this column, the dead load will cause compression. However, the lateral load would like to overturn this building like this. We expect tension due to wind load or earthquake. If you make combination between both of them, probably you have two scenarios. The first scenario, the dead load and the live load are bigger, so the final will be compression. Sometimes for very high-rise building, the net force on the column will be tension. So can you imagine if we have this composite column with steel column and steel reinforcement under tension, what will happen? As I told you, this composite column consists of concrete, steel column, and reinforcement. Anybody can tell me which material is working in tension? Concrete will not work in tension. Steel column can work. Steel reinforcement can work. So, if you are looking for the design tension strength of a column, in case the composite column, it will be phi Pn. The value of nominal strength will be F yield area steel, F yield reinforcement, area steel reinforcement only. One of you will say, hey, where is the contribution of concrete like you did last meeting? Last meeting, you told us we have 3 terms, one for steel column, one for reinforcement, one for concrete. This is the case if you have compression. But if your column under tension, we will neglect concrete. The steel column will work, the steel reinforcement only will work, and then we can find the nominal strength, multiply this nominal strength by reduction factor phi equal 0.9, you can get the tensile strength of the column, design strength of the column. Any question? Any question? Thank you, Oliver. Yes, so if your column under tension, we will neglect any contribution from concrete. Steel only will work. Steel only will work. So we don't like to reach to this situation. We don't like tension on a columns, because if the column under tension, that means we have material in the building doesn't work. Useless. Something useless. So you need to figure it out. You need to try to avoid any tension on the column. One of you will say, how can I avoid this? We need to figure out what is the statical system resisting this lateral load. We have many statical systems. So you can change your statical system to be fit with the case to prevent any tension on the column. But if you have tension, your design will depend only on steel beam, steel column, and steel reinforcement. We have example, this column with steel reinforcement and steel beam under the effect of dead load down, wind load up. Let's see. Probably we have compression, probably we have tension. Let's see. So we have dead plus wind. Anybody can tell me what is the value of P ultimate? I will open my first module and search for load combination between wind and dead only. Do you have here a combination between dead and wind only? Or dead and wind? I think the first one, no. The second one, yes. Probably 1.2 dead plus 0.5 wind. Okay. So the first one, 1.2 dead plus 0.5 wind. Anything else? We have 1.2 dead plus 1 wind. 1.2 dead plus 1 wind. Anything else? We have 0.9 dead plus or minus 1 wind. .9 dead plus what? 1 wind, or 0.9 dead minus 1 wind. So we have different fluid combination between dead and the wind. Anybody has any question for this one? So I went back to module number 1. We have different fluid combinations. By the way, one of the question in my PE exam on last October based on this fluid combination. The problem gave us values for dead load, live load, wind, earthquake, and I think there is another load, flooding load, rainfall load, and they are asking about what is the maximum effect or what is the maximum combination. Actually, we have different combination if you would like to include flooding and rainfall. Okay, so this case or these cases should be you should be familiar with. Anyway, so we have 1.2 dead, 0.5 wind. We have 1.2 dead plus 1 wind. So I will assume life equals 0, S equals 0, R equals 0, and so on. And we have here 0.9 dead plus or minus. Plus or minus means we have two cases. One for plus, one for minus. So here is the scenario. Go ahead and put your numbers. The value of dead is negative 260. So I will assume negative means compression. Positive means tension. Okay. Put the value of dead load, negative 260, wind 980, and find the values here and what's going on. So we have 1.2 times negative 260 plus 0.5 times 980. This one will be 178 tension, positive. 1.2 times negative 260 plus 980. We have positive 668 tension. 0.9 times negative 260 plus 980 will be positive 746. Wow. What else? 0.9 times D negative 260 minus. So we have negative 1214. We are talking right now about tension. I don't care about the compression. If this is the case, compression, you can solve it like the previous example, like I did last meeting. But right now, I'm looking for the worst case for tension. Which combination is the worst case for tension? We have tension 178, we have tension 668, we have tension 746. I think the P ultimate equal 746 tension. So this problem should be solved 2 times. The first time against the tension, the second time against compression. If you would like to check the column against compression 1214, you need to solve it like previous example. Does that make sense? But right now I'm focusing only on the tension worst case. Tension worst case. Okay, Pn equal F yield area steel plus F yield steel reinforcement time area steel reinforcement. That's all. Just one step. F yield is 50. F yield steel reinforcement is 50. Area steel, do you remember the value of area steel from last one? 10 times 45. because it's the same column. 13.3. What is the value of area steel reinforcement from the previous example? 6.32. I am done. 50 times 13.3 plus 50 times 6.32. This value will be 981 kip. But we need to multiply this nominal value by phi. Phi for column under tension is 0.9. So time 0.9 will be 882.9. I think right now the value of P ultimate is smaller than the value of phi Pn. We are safe. So if your column under tension, the life will be more easy because we have only one step. The steel contribution only will be considered, and then I can figure out the value of the design strengths, and then I can do a comparison between the ultimate load and the design strengths. Any question?
Dr. Amy?
Yes.
For your P ultimate, you said tension worst case, so you just go for the highest value since it's just like the worst case scenario?
Yes, the highest value of the tension will be the worst case in tension.
Okay.
And if this example in your exam, so we have two scenarios. The first scenario right now, your P ultimate equal 746 tension, worst case. And we have another scenario, the P ultimate equal negative 1214 compression. Under the effect of wind load and the dead load, we have two cases can be happened. So I would like to examine, I would like to check the column. So we have to solve the problem two times. The first one, the column under tension, like I did. The second one, the column under compression, like we did last meeting.
And it should be the same equation for both, correct?
No. For both what?
For both your tension case and your compression.
No. If the column under compression, right now the concrete will work. And the steel column will work. And the steel reinforcement will work. So we are going back to this scenario for compression. But if the column under the effect of tension, no, we have only area steel and area steel reinforcement only, because concrete will not work. Does that make sense?
So you recommend we do compression first, of course, and then move on to the tension case?
Okay.
So does it matter? Wouldn't it make sense to do the compression first?
Okay, that's fine, because I did compression last meeting. Okay. You need to repeat this example one more time that I did last meeting. Under compression, what is the area steel? What is the area steel reinforcement? What is the area concrete? And then to use this equation for BN node and check which one I'm gonna use, this one or this one. You need to do all of these calculations to find what is the value of phi Pn and compare it to 1214 in compression. And then you need to solve the problem one more time, like I did today. but it will be very simple, and all information you need will be covered in the first one for compression. So I agree with you, Parag. Go ahead and do the compression part first, because all information needed in the tension part will be available from the first step. Okay? But if sometimes, if all of load combinations give you compression. Okay, so we have only one case, the column under compression. That's all. Probably all load combinations give you only tension. So your case is tension only, because you are lucky. These combinations give you values in tension and the value in compression. So we have two scenarios. We have two different situations. So we need to check both of them. I agree with the Burak. Go ahead and start with the compression. If you are in the exam or the in your homework, start with the compression part and then check your tension part, because the tension part is very easy and the most of information will be used from the first step. The second type of column, which you called filled composite member. The filled composite member is common in this scenario. We have a steel tube filled with concrete. That's all. Sometimes this steel tube looks like this shape, rectangular shape, which called HSS shapes. This shape can be called HSS. I will show you the table. You can get all information about this tube, this rectangular or circular tube. Okay? And this tube filled with concrete. That's all. So we have two types of composite column. The second one called filled composite member or composite column. The previous one called encased. That makes sense? So sometimes we have additional reinforcement, sometimes no. But most of the time, no, we don't have. We have only steel tube filled with concrete. That's all. That's all. So the design compressive strength of axial eluded double symmetric filled composite member shall be determined for the limit state for flexure buckling. For compact section, this is the only case I will cover in this course. PN node equal PP, plastic load. The plastic load equal F yield time area steel plus C2 time F prime C of concrete time area concrete plus area steel reinforcement, and I will convert it to equivalent of concrete, E steel divide E concrete. The constant value C2 equal 0.85 if you are talking about rectangular section, equal 0.95 if you are talking about round section. Let's do this example. We have filled composite member under the effect of dead and alive, because your loading are dead and alive only, so it will be very easy to figure out the value of P ultimate, which equal 1.2 dead load plus 1.6 live load. We don't have anything else. Probably we have, but this is the worst case, 1.2 dead plus 1.6 live. So your value of dead load, P ultimate, will be 1.2 times 32 plus 1.6 times 84, 172.8 cap compression. because this one is filled composite column, so the value of Pn equal the value of P plastic. So your value will be F yield time area steel plus C2 F prime C time area concrete plus area steel reinforcement time E steel, I think, divide E concrete. This is there. Yes. My question is, do you think we have steel reinforcement inside the column? No. So this term will be 0. What is the shape of the column? It's a rectangular shape. So rectangular section, the value of C2 equal 0.85. So your equation became Pn equal F yield time area steel plus 0.85 F prime C area concrete. That's all. This steel tube is called HSS 10 times 6 times 3/8. I will open my tables and I will go, I think I will go down. Too much here. There you go. This one is for circular shape, HSS circular. So keep going down. Wow, we don't have probably I will need to go up before the circular shape. Here you go. Yes. So I'm looking for which one? HSS 10 times 6. 10 times 6. I need to go up. 10 times 6. This one is square. So I need rectangular. There you go. 10 times 6, 10 times 6. There you go. 10 times 6. But your cross section is 10 times 6 times 3/8. So 10 times 6 times 3/8. Here you go. This one. Everything you need about this tube, like the thickness, like this length, like this length, everything you need, you can find it. You can find it. So 10 times 6 times 3/8, which is the same here. We are looking for area of steel, 10.4. So the area of steel, 10.4. F yield, 50. 0.85. F prime C, 5. What is the value of area concrete? What is the value of area concrete? Any answer? This area is area of steel, the area of the wall of the shape. So area of concrete will be the area inside, but we have issue here. This length from this side to this side is 6. And this length H equal 10 from this side to this side. So how can I do the inside area? So we need to figure out what is the thickness of the wall. Design wall thickness 0.349. So this thickness 0.349. And we have another thickness on the other side. So I think the dimension will be 10 minus 0.349 times 2 times 6 minus 0.349 times 2. So the area of concrete will be 49.3. So guys, to explain it to you, this cross section, this total length is 10. This total length is 6. This is the meaning of HSS 10 times 6 times 3/8. This 3/8 will be this thickness. Or you can find the thickness from the table. If you would like to get the area of concrete inside, so this length is 6, I will subtract 2 thickness from this side and this side. This length 10, I will subtract 2 thickness, this side and this side. Then I will multiply the 2 dimension to find the area concrete. It will be 49.3. So the value of Pn will be 729.6 kip. I will multiply phi Pn, the value of phi. What is the value of phi? 0.75. So times 0.75, your value will be 547. So right now, your P ultimate equal 172. The design strength equal 547. I think P ultimate is smaller than phi Pn. It's safe. It's more safe. So please pay attention that we have another cross section called HSS. Probably it can be rectangular shape. Sometimes it can be circular shape, which called tube. And also it can be square shape. Here you go. Here is the round HSS, which called steel tube. This one will be filled with concrete. So how to design filled column? I think it's more easy in comparison to the encased one. Anyway, what will happen if this filled column under the effect of tension? What do you think? The same idea. I think this term, area concrete, will be cancelled. So the equation will be area steel F yield plus area steel reinforcement F yield reinforcement. That's all. And your phi became 0.9. So this column, we have dead load and wind load, negative 32. So I will assume negative is compression. Positive will be tension. Let's start. So P ultimate probably equal, do you remember the case of loading? 1.2 dead, 0.5 wind. Or 1.2 dead plus 1 wind. Or 0.9 dead plus 1 wind. Or 0.9 dead minus 1 wind. Go ahead and put your number. The value of dead load, negative 32. The value of wind load equal 100. What are the values? 1.2 times negative 32 plus 0.5 times 100. We will have positive 11.6. 1.2 times negative 32 plus 100. Positive 61.6. 0.9 times negative 32 plus 100. Positive 71.2. 0.9 times negative 32 minus 100. Negative 128.8. So right now we have two scenarios. The maximum tension equal 71.2 kip. the maximum compression equal negative 128.8. Okay, for compression, this value is smaller than 547, which is safe. We don't have issue with compression. We don't have issue with compression because the column under compression, the design strength equal 547. However, the force in compression is 128. So it's safe. What about tension? We need to figure it out. So the value of tension equal F yield area steel plus F yield reinforcement area steel reinforcement. That's all. Very easy. Very easy. So F yield 50, area steel, how much? For this cross section, 10.4. Do you have steel reinforcement? No, we don't have steel reinforcement. In this column, we don't have steel reinforcement. We have only concrete and the steel tube. So your value will be 520, Phi PN, Phi equal 0.9, 468 kip. So I think the value of P ultimate, which equal 71.2, is smaller than Phi PN. The column is safe. So if you have a problem in your exam or your homework or in your life, you need first to figure out, do you think this column is encased column? Do you have a steel beam embedded inside concrete? If this is the case, we need to follow these steps if the force is compression. If the force is tension, we need to follow this step if the column is encased but under tension. If the column is filled under compression, we need to calculate what is the value of P plastic, and then you need to multiply this P plastic by Phi 0.75 to figure out the design strength. If the filled column under tension, we need to use this equation and make sure, do you have steel tube? I believe yes. Do you have steel reinforcement? Yes or no? Sometimes yes, sometimes no. And the Phi value will be 0.9. So this slide in this week can help you to design any composite column, encased or filled. If the column under tension or if the column under compression. What will happen if I have the column under both of them, sometimes tension and sometimes compression? Then you need to solve both of them. So you have two problems in one example. You have to check the tension and you have to check the compression, both of them. And I recommend to start with the compression part first and then the tension part. Any question? Cody, what do you mean by can you just do 60 area steel? Oh, okay. Yeah, we don't have steel reinforcement. So if yield is 50, I think. Your question, Roberto, when would these column types be used? I answered this question last meeting. Do you remember? Here you go. Sometimes, if you decide to use concrete column, like we did last semester in concrete design, probably this side and this side 5 feet or 10 feet or 15 feet, very huge. Looks like it will occupy half of your bedroom. Or if we are using a steel column alone, the cross section of the column will be very thin. Or we have worrying about fire or buckling or something else. So what do you think if we do combination between both of them? But to be honest with you, and the direct answer, to give you a direct answer, composite column will be used in high rise building. You are talking about building with 30 or 40 floors and above. If you have this number of floors, I expect a huge reaction at the bottom on the column. This huge reaction cannot be supported by concrete alone, cannot be supported by steel alone. We expect buckling. So the best scenario to construct composite column, concrete with a steel column, and the reinforcement also. So this type of columns will be used in high-rise building if you are building more than 40 or 50 floors. So if you look to the building in Dallas, in the downtown in Dallas, I believe these columns are composite. The high-rise building in Chicago, the column of this building are composite columns. But if you look to the column in your house, no, it will be from wood, not from concrete at even. Does that make sense? I was talking about the columns covered in steel, like our example. Okay, let me highlight this also. Which one is best? Encased column or filled column? What do you think? Which one is better? Any answer? Which one is better? To use filled composite column, or encased composite column? What do you think? Try to think. Both of them has advantage and disadvantage. Okay, let me explain it. For filled column, we don't need formwork. You have the tube, go ahead and fill it with concrete, that's all. But for encased column, no, we need to construct formwork first around the column to fill it with concrete. After hardening, we will remove the formwork. So we have advantage for this one, disadvantage for the other one. I'm sorry, vice versa. Formwork is not good because we need to wait time 6 days or 7 days to remove the formwork, and we need to more workers and more hands. The second one, concrete outside, steel embedded. This one is a good fire protection. But in this case, no, the steel is outside and the concrete is inside. So if you have fire, no way, steel will start first. So this is disadvantage. One more thing, corrosion. I think steel here is protected against corrosion because it's embedded inside concrete. But in this case, no, we expect corrosion because the steel surface is exposed to environmental change. So we have advantage and disadvantage. Which one is better? It's up to you as engineer. What is the conditions in your construction, in your building, in your structure? And then you can decide. Does that make sense?